Right.
So it would be
Right.
I mean, out of the total number of people.
70%. So the probability that if I pick somebody out of this group that they have a score of a 3, 4, or 5 is 0.7. 70%.
Okay, so it is out of the total number of people.
Yes, yes.
Okay, that's
Notice just one thing, that this right here is the exact same as saying 1 minus the probability of scoring a 1 minus the probability of scoring a 2. In other words, the probability of getting a 3, 4, or 5 is the same as the probability of not getting a 1 or 2. It's the same thing. If I get a 3, 4, 5, I must not have gotten a 1 or a 2. Karina. No. It's just like me explaining. These are the same. Yeah, the same. Let's stop, see if there's any questions on A through C. All right, let's restart the video, Alex, so I can erase. Oh, you already did? Okay.
Yes.
So does anybody still need this up? Okay, great.
Great. So far, this looks so easy. Yeah. I'm kind of.
All right, guys. So let's push forward. All right. So now we're at D. D says find the expected value of x. So here we have a new vocab word, expected value. This is just another word for mean. Just another word for average. On the AP exam, you guys are familiar that they give you a formula sheet. One of the formulas they give you is for expected value. So we can go ahead and copy this down. This is an important formula. The expected value, bless you, is equal to, it's the exact same thing as the mean. Remember, this was the Greek letter mu represented mean. Is equal to, and I'll just write the formula, then I'll explain what this says.
I thought you were gonna write like stigma.
That's an E?
Yeah, it's like a sigma. The Greeks signed sigma. I'll explain what this means. Go ahead and copy it down.
I did not want you to write that. Sigma I.
So what this is saying is the following. What this is saying is the following. They said, and I'll explain in words, then I'll apply it to this problem, then we'll see how to do it on the calculators, which will how we'll do it for the rest of the time. Let's explain in words. So in words, this is saying, take the first x value, so the first score is a 1, and multiply that by the probability of getting a 1, which is 0.1. So we take the 1, which is the first possible score, and multiply that by 0.1. Sigma just means add. So then add the next x value, 2, times the probability of getting a 2. Then add the next x value, 3, times the probability I get a 3.
Do we just continue?
Right, up to 5.
Okay, this is good.
No, it's actually really easy.
No, it gave me how
Shun Lee?
Whenever you're doing that, does it have to use decimal form?
Yes, decimal.
I do not think so.
So now, what I've said is, the expected value just means what is the average, or what is the most likely value if I just randomly pick a person? Like, what are we likely to get? Well, it's probably going to be somewhere around 3. A, that's in the middle. B, we have a lot of people who get a 3. We can find exactly what it is by saying, let's do 1 times 0.1, because the probability of scoring a 1 is 0.1, plus 2 times 0.2. The probability of scoring a 2 is 0.2. Plus 3 times 0.35. The probability of scoring a 3 is 0.35. Plus 4 times 0.25. The probability of getting a 4 is 0.25. Plus 5 times 0.1. The probability of getting a 5 is 0.1. And if I do this on my calculator, you will get, we don't need to all do it now, but we get a 3.05. So what this is saying is this is the score I should expect if I randomly pick somebody from here. So I randomly pick somebody out of the 20, the average score is a 3.05. The average score is a 3.05.
How reliable is that conclusion?
Well, so this conclusion, how reliable is it? Well, on some hand, maybe it is reliable because I just picked 20 people out of my spreadsheet. But maybe it's not reliable if I just picked 20 people in like one class period. Maybe that class period does a lot better than all my other class periods. Who knows? Can't say. So how does this happen on the calculator? Let's find out. So I'll model on both calculators. Who has 8384? Okay, so let me model on this first. So 8384, the first thing we want to do, and I wish this, but the DocCam doesn't work, so it would be really important just to like listen really closely. So for 8384, we click Stat, 8384, and then we'll do Inspire. We click Stat, we click Edit, and now we have two lists that pop up. Actually, we have L1, L2, L3, blah, blah, blah. In L1, put the different possible values. 1, 2, 3, 4, 5. Let's go ahead and do that. In L1, we put the different possible values. In L2, we put the probabilities as a decimal. In L2, we put the probabilities as a decimal. Okay? So now we have two lists, and now we click Stat. We go scroll right to Calc. Fruity, you with us? Scroll right to Calc. Click one var stats. And does it pop up with saying list? Does it say list? Do you have a list, Frida? So for list, it should say L1. And then frequency is L2, because we put the frequencies in L2. And then you can go ahead and click calculate. Does it pop up with 3.05 for X bar? Chun-Li? Norma? Are you getting 3.05 for X bar? No? What are we getting? 3? 3.000? No. Do we not put the... Did you have a chance to put frequency? Take a look. Oh, so under frequency, you need to put L2. Frequency, you need to put L2. There we go. So, Chun-Li, under frequency, you need to put L2. Frida, did you get this? No? Under frequency, we need to put L2. After this, we go Stat. We go right to Calc. Put one bar for the answer.
No, I'm no. No, I'll tell her.
I need to check this calculators. Now on the Inspire, hey guys, on Inspire, can we turn the calculator on, please, for Inspire?
Okay.
Click New Document. No, you don't really care about saving. Then you want to go to Lists and Spreadsheets. And then in column 1, I would call it X and put in the scores. In column 1, call it X and put the scores in. In column 2, call it Y and put the frequencies in. 0.1, 0.2, they must be in the same order. Chun-Li, you got it?
Hey, do you still need these videos?
Yeah.